Oh, okay, I see.
Okay? That makes sense?
So in this case, maybe you'd have like 13 for x minus floor over
And-
12.
I'm using the left arrow. In the programming language I'm stuck with, because I can't get anything else to install on our computers, I have to use an equal sign. And that's actually kind of standard, but I want to use the arrow, okay? Okay, so now what I'm going to do is I'm going to replace z again. Okay, so what I've got is I've got the remainder of of my division x over 12, right? Okay? Then I replace z by 12 times that. Okay? And then I'll go ahead and use z. Okay? And I'm gonna do it a different way. I don't want to use an if then there. It's a little more elegant. Do something else, and you'll be able to handle it. Okay? It's a little cramped there. It says as long as z is greater than or equal to 12. We're going to output z, we're going to end. Now let's trace this and see if it makes even remote sense. Okay? So again, x is 37, right?
Yes.
Okay? So, now z is 37, right?
Yes.
Now, as long as z is greater than or equal to 12, well, z is greater than or equal to 12, so we proceed. Z is less than x over 12. Okay?
What? Excuse me?
I'm sorry. Z is replaced by x over 12. What's x over 12? 37 divided by 12 is what? It's 3 and 1/12. We don't do decimals. Okay? We do fractions because we're dealing with integers. Okay? So what's the floor? I've got x here. So there's a bug in my program. I've got to debug that. I've got to change my x to z. Okay?
Wait, why?
Okay? So what is z over 12 minus the floor of z over 12?
Wait, okay, yeah.
Why?
1/12?
Exactly. Because z over 12 is 3 and 1/12, right? Okay? And when you subtract, what's the floor of 3 and 1/12? Well, it's 3. So you end up with 1/12. In other words, this is just a remainder. Right? So you can actually do it using the division algorithm and get the remainder, and it's going to be equivalent to this, which is easy to prove. Okay? So the remainder is 1, right? Well, actually, I mean, it's not the remainder, it's the remainder divided by the divisor, okay? So it's 1/12. Now you multiply that by 12, you get what? 1, which is the remainder, right? So now this is just a remainder when you divide your x by 12, okay? And now what? You replace z by z plus t. What's t? 2. And you add 1, you get 3, right? Okay, now I should have terminated this. I'll just say repeat.
Why did you change that? Change those to C.
The as long as. Now, if you get back to here, and z isn't greater than or equal to 12, you're done,
You have
right?
it? Okay, yeah.
And then you
X
skip
is
down
the-
here and you output z.
Z.
So, a little clumsy, I could have structured it better, but there's the idea. Now, let's go ahead and trace it through.